This learning object is a production of Abu Dhabi Men's College, Center of Excellence for ICT and Learning Technology.
How to find the boiling point of crude oil. Now, when you find the boiling point of chemicals, usually they're single chemicals. So, for example, water boiling point is 100 degrees C. So now for crude, when you try to find the boiling point, crude is consisted of many things like kerosene, gasoline, jet fuel. It's just different products inside the fuel. So it's not simply that you're going to stick a thermometer and find the boiling point. So there is a method to do that. Now, it's a little bit more complicated than water, but the way I'll show you the way you can do that. So the way you do it, first of all, you need to do distillation to separate all the components of the crude. So you need to have kerosene coming out, you need to have the gasoline, you need to have the diesel coming out. And then what you can do is you can measure the boiling point of the separate components. For example, kerosene, gasoline. So the lighter ones will have a lower boiling point, and the heavier ones will have higher boiling point. So you have a mixture of temperatures. Then after that, you need to average them. Now, the way you average is not simple as taking three numbers and divide by 3 or 4. It's a little bit different. It's similar but different. So the way we do it is using charts. Now, this is a very important chart of how to find, we call it the mean average boiling point of crude. So the way we do it, everything is on the chart. So if you look in the top equation, it's the mean average boiling point is equal to the volume average boiling point minus differential. Now, what does that mean? If we look at this, the volume average boiling point is using this equation. Now, what this equation means is, if you look there, you find 20% volume of the crude. What is the boiling point of the 20% of its volume that came out, of the fraction? What is the temperature, the boiling temperature of the 50% of the volume? And what is the boiling point temperature at 80% of that volume? And you do the same thing here to this equation. So this number here is called the volume average boiling point. That's what you're going to stick there. Now, this number here is the slope. You just read from the chart to the volume average boiling point, and you get your differential, so you can put in your equation. So after you do this, you'll get the mean average boiling point of the crude. Now, there's more charts and more, but this is like a simplified way, but it gives you an idea. Now, why is it important to find the mean average boiling point? And this is what we'll show you. Okay, there is something here called the Watson factor. So this number TB here is the mean average boiling point. So you cube it and divide by the specific gravity of the crude, which you can measure simply in the lab easily. Okay, it gives you a number. Now, that number is very important. It's called the Watson factor. Why is it important? If the number, the value of the Watson factor is 10, it indicates highly aromatic crude. It means lots of rings in the crude, the carbon structure. So you have, like, for example, lots of benzene, lots of diesel, heavier components. If the number is 12.8 and above, it's highly lighter crude. Like we call them paraffins, like methane, ethane, propane, butane. So now, when you know what's your crude, is it highly paraffin or highly aromatic? What you can do, then you can design your fractioning better. Your fractioning towers, your distillation towers. You can know how many trays you have, how many plates, and so on. So that's the idea, and it's a very important thing to do. Before you start analyzing your crude or production, you need to know what type of crude you have. To find the mean average boiling point of crude, like we mentioned, we need to fractionate the crude. Basically, we need to use distillation. In other words, we need to separate. We need to separate the different components of the crude. Now, this setup here is a result of fractioning that we did actually in a lab, and we kept the samples. So if you look on this side here, this is the crude, where you see it's a very thick material because it has, many components in it, or different components in it. Now, and there's a thermometer here. So basically what we do, we use equipment. We boil this, and then you get, the lighter components will vaporize, and we collect them here. So when we collect them, so after we collect, for example, this first sample here, this is the lighter one, and you can even see the color. Then we read the temperature after we collect it, and that's the boiling point of the first sample. And then we do it for the second sample and collect the boiling point, for the third sample and collect the boiling point, and for the fourth sample and collect the boiling point. The reason I wanted to show you this is so you can see this is like light, this is heavy, heavy, heavy. So this could be, for example, like gasoline, for example, and it ranges from gasoline until we get to the diesel, which is a heavier crude. And then we can find the boiling point of each one and then go to the chart and do the averaging and find the average boiling point of all these components. To find the mean average boiling point of crude oil, like we mentioned before, what we need to do, because what we need to do is we need to fractionate the crude. So this is a picture of a crude, which is a mixture of kerosene, gasoline, fuel oil, jet fuel, all kinds of fuels, the light ones and the heavy ones, and diesel, of course. So what we do, we take this and we put a thermometer in the crude. Basically, we're fractioning, or we're doing distillation. So we boil this one, and we collect samples. So for example, this first sample that comes out, the vapor comes out, condenses, and comes down, we collect it. And then we get the boiling point of this one by reading the temperature. So this is the boiling point of the first one. And then after that, the second one starts coming out. And then after it comes out, we get the boiling point of that. I mean, at the beginning and at the end, there go two of them, and we average. And then the third one, and then the fourth one. So basically what we did, we separated the type of components inside the crude. So for example, this could be, the first one could be gasoline oil, and they range down from kerosene, naphtha, until you get to diesel, which is the heavier one. And you can even see the colors. So after we have all the components boiling points, then we use charts like we showed to find the mean average boiling point. And then we can, from that average boiling point, we use a Watson factor, something called the Watson factor, which includes the boiling point, to get an idea. It gives us the number, and like we mentioned, the number can tell us or give us an idea, about what type of distillation equipment do we need, how tall the distillation tower is, how many trays, and so on. And this is basically how you do it. We do distillation of the crude. We get the different products from the crude oil. So for if you see these test tubes here, so the first one here, the first test tube has, for example, gasoline in it, which is the lighter fuel. And then the next one will have, for example, we can have naphtha or kerosene. And then the last one we can have diesel, which is a heavier oil. And you can see the color. It goes from light to dark based on boiling points, lower boiling point to higher boiling point.